All right, I'm going to walk you through how to do a factorial ANOVA one more time. Okay, I'm using a data set from 2015 paper which tested the effects of different TV shows on social cognition as measured by the eyes test, which we can see right here. This is our dependent variable, the outcome variable. So participants came into lab and they were randomly assigned to watch either documentary or award-winning drama. And there's also a control condition that they did not watch anything. They just took the eyes test. Okay, so we have three conditions: documentary, fiction or award-winning drama, and control. We also asked for their age and their sex, right? Okay, and ART is just a measure of lifetime exposure to fiction. All right, so to run a factorial ANOVA, you hit Analyze, General Linear Model, Univariate. Okay, let's reset this. We put our dependent variable, in this case it's a true dependent variable because there's a manipulation and random assignment, okay, in the dependent variable field. We put the fixed factors, which are type of TV show, and sex in the fixed factor in the factor field, right? We're going to put in sex first. I just prefer it that way. It doesn't really matter. And basically the idea here is to control for sex. The true independent variable is the type of TV show, but mostly when you publish something in social psychology, you want to control for the effect of sex. This is especially important with things like emotional social cognition because females tend to score higher in these type of tests, right? So we add type of TV show there. Okay, next, let's just go straight down here. Let's do plots, okay? Let's put group, that's the condition, TV condition on the horizontal axis, and sex separate lines, right? We're going to put add. We're going to select a bar chart and error bars, okay? Hit continue. Post-hoc tests, we want to add, we're interested in our TV group, and it has 3 levels, so we want to put that in there. We're going to put Tukey, right? And hit continue. We're going to get the estimated marginal means. That means the means controlling of each controlling for the other. And we're going to move them all into the display means for field. Hit continue. Select options and select descriptive statistics and estimates of effect size. Hit continue. Hit OK. All right, let me change my share so you can see the output. Here we have our output window. Now let's break this down slowly, okay? First, we have the between subject factors, which are 2 factors. We have sex. We see we have 67 males and 108 females. We had 62 people in the documentary condition, 53 in fiction or award-winning drama. Actually, the documentaries are award-winning here too. And 60 people in the control condition, right? Here's our descriptive statistics. So this is mean scores on the eyes test for each condition. So let's just think about this. This is a 2 by 3, 2 groups of sex and 3 in type of TV show. So 2 by 3 ANOVA, which means it has 6 cells. All right, so we can see these means broken down by cell. So we have 1 cell, 2 cell, 3 cells. Look, that's lower, definitely there. 4 cell, 5 cell, 6 cells. So those are the means for our 6 cells. Okay, right here, this is just total for males, 25.88, right? 67 males. This is total for females. Okay, this is total in documentary, fiction, and control. Okay, all males and females all together. In documentary, the mean was 26.53, right? Now, if we entered the type of TV show first and sex second, this would have been a little different, but basically the table works the same way. All right, so let's scroll down a little bit and look at the main ANOVA table tested between subjects effects. Okay, so first, okay, we're going to worry about, okay, this is an intercept. We really are only going to worry about these rows, right? This is the main effect of sex, the main effector group, and the interaction. All right. So we can go look over here. We see degrees of freedom 1 because there's 2 groups, and degrees of freedom for sex is the number of cells minus 1, which is 1. Okay. Degrees of freedom per group is 3 minus 1 is 2. Right. So anyway, Over on sex, we can see there's no effect of sex, right? It's greater than 0.05. We do see there's an effect of TV group, right? Of TV show condition, right? 0.002. So this is P equals 0.002. That's significant. So we need to look at those pairwise comparisons. And we see there's no interaction. There's no interaction for sex times group, right? Scrolling down, we see estimated marginal means, right? So overall, we have 26.00 for males, 27 for females. So it does look like there's a difference, and with more people, it might be statistically significant, but it isn't here, right? You can also see that up here, right? We can see that the values are, if we look at our descriptive statistics table, and this is important. See, the mean here is 25.88 for males, right? Let's look at this. Okay, so 25.88 females is 26.98, all right? Look down at our estimated marginal means. They're a little bit different. This is because this is controlling for TV condition here for your other variables in the model. So it's 26 and 27, right? Okay, scrolling down, we can see the estimated marginal means for TV show. We can see that the highest mean is clearly fiction. Okay, so people who viewed award-winning dramas did better on the ICE test, followed by documentary, and finally followed by control, right? Okay, and then we have marginal means split up by in each category. We can see here, let's actually get a pencil here. We can see the lowest looks like males who were in the control condition, who viewed nothing, had the lowest scores, mean score on the ICE test, 23.79. And the highest scores looks like females who viewed award-winning dramas, 28.29, right? Okay, so down here, finally, in our multiple comparisons, scroll down a little bit more. These are our Tukey tests. Okay, so here we're just going to look for pairwise comparison. So here, this compares documentary with fiction, and there's not a significant difference. Documentary versus control, not a significant difference. Fiction versus control, there is. So people who viewed fiction scored significantly higher on the ICE test than people who viewed nonfiction, right? So this is the only Tukey test significant difference right here, 0.00. And the mean difference was 2.72, right? And you could calculate an effect size with that if you want to find D. You divide this by the root mean square residual, which that's beyond the scope of this class, but you could do so. You look at here at the homogeneous subsets table, and we can see that, yeah, documentary is not significantly different from either, but control and fiction are significantly different. All right, so that is how you run an ANOVA. Let's look at the, oops, we got to look at the plot, right? So here we can see for May on the y-axis is mean ICE test score. The x-axis is type of TV show. So this is one way to visualize it. We can see little differences, of more differences between males and females in the control condition. This kind of suggests that maybe what watching fiction or anything does is increase males' ability to perform on the ICE test. I never thought about that, but when you look at this, you can see, especially for documentary, in the documentary condition, males actually do better. It's not significant, right? But it looks like they're a little higher than females, which is interesting because, you know, there's an entire theory that's saying that holds that males are more drawn to nonfiction because of autism spectrum things. It's really interesting, actually. Anyway, so that's how you get and you can see the bar chart and you can see the error bars. If we put sex on the x-axis, it might be more interesting. Let's run that really quickly. Okay, so again, general linear model, univariate. The only thing we're going to change is the plot. Okay, we're going to remove, and we're going to put sex in the horizontal and group in separate lines, add, continue, hit OK. And let's just scroll straight down to look at the difference. So if you do it by sex, you can see like this, and we can see that it looks like, you know, males overall or less, but you can also see that there's no interaction anyway. If there was an interaction, we'd see something interesting, but we can see it this way as well. All right, that is good. Let's stop the video.